All right, for the last one, the pink one right here, we're trying to find the absolute minimum. Now, this one's weird because this absolute minimum does not give us, or this problem doesn't give us endpoints. So we don't have to test endpoints, but we do have to find critical values and test those. Now, if we have no critical values, then we don't have an absolute minimum or a local minimum. Okay, so f prime, let's see, what's that going to be? You have to do the product rule because we have x multiplying to natural log of x. The derivative of x is 1 times the natural log of x plus we have x times the derivative of natural log of x, which is 1 over x. And so when I simplify this a little bit more, I get natural log of x plus x over x, which is 1. X times 1 over x is x over x, and that would simplify to be 1. So here is my f prime. I can't think of anywhere where the f prime would not exist except for negative values, possibly. Yeah, negative values. Because if I looked at natural log of x, it would look like this. And if I have this plus 1, it's just going to move this function up 1. But it looks like I'm not going to be able to plug in negative x's because I won't get any values for that. So I take natural log of x plus 1 and I set it equal to 0. I get negative 1 natural log of x. All right, where does natural log of x equal negative 1? Let's get the x out of the natural log by raising both sides to base e. And then I get x because base e and natural log are inverse functions. And then I have e raised to the negative 1, which also equals 1 over e. Okay, 1 over e is a critical value. But is it the absolute minimum or is it an absolute maximum? Ooh, that's a very good question. In order to find that out, there's two ways. You can use the second derivative test or you can use the sine line graph, which is what I'm going to do. So this is my x-axis. This is going to represent f prime. And this is going to be 1 over e. So we need to find two numbers that we're going to test. Number before 1 over e could be 0. And then the number after 1 over e could be 1. Because e is like 2.7 or 2.17, I can't remember. So that would be 1 over 2, which would be between 0 and 1. So I can test 0 and 1 in f prime. So if I plug 0 into f prime, what do I get? Let's see. F prime is, natural log of 0 plus 1. Okay, now, natural log, reminder guys, is the what power function. And natural log has a base of e. So it's what power of e gives me 0? And the answer is nothing. Nothing. You can't raise a base to any power to get 0. So this is non-existent here. So it does not exist, which isn't helpful because I need to know if we're increasing or if we're decreasing right here. Let's try the 1 and see what happens there. And then we'll come back to the other guy. So I have natural log of 1. What power of e gives me 1? What power of e gives me 1? That would be 0. So I have 0 plus 1. E raised to 0 power equals 1. That's why this equals 0. Okay, so 0 plus 1 is 1. So this is positive over here. But we need to know if we're positive or negative before the 1 over e. Now, most likely it's going to be negative. Why? Because if you look at a graph, the what is it called? The slope or the derivative is negative and then positive. And that's where you have your local minimum or your absolute minimum. So chances are this is going to be negative right here. And so I could just take the guess and say, all right, cool. I just need to plug in 1 over e to find my absolute minimum value because that's a y value. Or I can test a number between 0 and 1 over e. So I think what I would do is I would plug in 0.1 if I wanted to test it. Or I can do the second derivative test. And if the second derivative test says that we're concaving up at this x value, then we know that we are at a local minimum. And actually, that's what I want to do. I don't want to pick a number between 0 and 1 over e, because I'm not 100% certain. I mean, I'm pretty certain that 0.1 would work here, but I don't have a calculator to confirm that, and I'd rather be really, really sure. So f double prime would equal, f double prime would equal 1 over x. It's just 1 over x. Yeah, because the derivative of 1 is 0. And so where, if I plug in 1 over e to this, that would be f double prime 1 over e. This is second derivative test, by the way. I have 1 over e, and that's is that positive or is that negative? Oh, no. Yeah, that's what we're looking for. Are we positive or are we negative? This is definitely a positive number. And if f double prime is greater than 0, if it's positive, that means we're concaving up, which is what this guy is doing right here. He is concaving up. We're positive. F double prime is positive right at 1 over e. And so that means pretty much 1 over e is right here, and we have a local minimum. All right, so now if we want to find the value, the y value, since we know that that's where the local minimum is, we got to plug it back into f and see what we get. So we have 1 over e, or you can plug in e to the negative 1. So we have 1 over e, and then we have natural log. I'm going to put e to the negative 1 inside of that because I know natural log and e are going to cancel out. And then I get 1 over e times negative 1, which equals negative 1 over e. This is our absolute minimum value.